Hi guys, welcome back. So today we are going to be talking about section 3 of chapter 7, Radian Measures. So when we talk about measuring angles, the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. There are two common ways to measure angles, in degrees and in radians. We will start with degrees because we are the most familiar with that, and that is what we have kind of grown up knowing about. So 1 degree is equivalent to a rotation of 1/360th of one revolution, meaning there are 360 degrees in one whole revolution around a circle. Now, before we really get into radians, I kind of want to make a broad note about what they are and how we want to look at them. Degrees and radians are both measurements. It's the way that we can measure angles. And we can think of this as how we compare inches and centimeters to one another. We can both measure the length of something using either inches or centimeters, but they have different lengths. We can convert back and forth from one another, just like we can kind of convert back and forth between degrees and radians. Degrees, we tend to see integer values, whereas radians, we're going to be dealing a lot with pi. So as we move forward, you will get to know pi very, very, very well. So first I want to talk about what even is a radian. So to define a radian, we're going to consider a circle with a radius r. 1 radian is the measure of an angle in standard position, which means the vertex is at the origin, whose terminal side intercepts an arc of length r. So what does that even mean? So we're looking at both of these lime green lines here, which I will highlight in purple. This and this both have the exact same length of r. Now our arc of the circle, or the length of this curve, is also r. So in a sense, if we had straightened out this circle, we would be getting an equilateral triangle. However, because this side is curved, we cannot say that we truly have an equilateral triangle. However, that is the measurement of a radian. So here's the definition of a radian. I would like you to write this above number 2 in your worksheet. A radian is the measure of the arc of a unit circle, and the arc is just this distance around the curve. And something to keep in mind, a unit circle is a circle with a radius of 1. So in essence, each of our radii have a length of 1, and this arc also has a length of 1. Now we want to be able to figure out exactly how many radians are in a full rotation. So in order to do this, let's go ahead and find the circumference of a circle with radius 1 so that we know what the entire distance or entire length of our circumference is. So now the equation for circumference is 2 pi r, or 2 times pi times the radius. And in this case, our radius equals 1. So we can go ahead and plug in 1 for our radius. And 2 pi times 1 is just going to be 2 pi. So we know the length of our entire circumference is going to be 2 pi. We also know that 1 radian is going to be a length of 1. So in order to figure out the number of radians in a circle, we're going to take our entire circumference, which is 2 pi, and divide it by the length of 1 radian, which is 1. And therefore, we get 2 pi radians. We can shorten that for rad. So there are 2 pi radians in a full rotation. Here's an example of kind of what we just did. We found the circumference of our unit circle. We took the entire unit circle divided by our radian, so that's the arc length S divided by arc length R. And therefore, we ended up with 2 pi radians. It's important to note that 1 full revolution also equals 360 degrees. So in essence, 2 pi is the exact same as 360 degrees. So now for part 3, we want to draw a circle with radius 1 in terms of quadrants. So let's talk about how this is constructed. We know that in 1 full circle, there will be 2 pi radians, which means if we only travel half of the way around, we are going to end up with pi radians, since 2 pi divided by 2 is pi. If we cut this in half, we're going to get half of a pi, or pi over 2 radians. And then if we continue around from pi and add on a half of a pi radians, we're going to end up with 3 pi over 2 radians. So we can kind of equate this in degrees. 2 pi is going to be the same as 360 degrees. Half pi, or pi over 2, is the same as 90. Pi is the same as 180 degrees. And 3 pi over 2 is going to be equivalent to 270 degrees. Now the last thing that's really important to note on this slide are the quadrants are the exact same as before. So we're going to start with quadrant 1 in the positive quadrant and then move counterclockwise around. So everything that is circled in this image, make sure you have written out for problem number 3. The ranges represented here are just the ranges of the radians for that specific quadrant. You're more than welcome to write that, but it is not necessary. So go ahead and pause this video if you need some additional time to write. Now that you have that drawn out, we don't want to forget about coterminal angles. The nice thing is that coterminal angles work in the exact same manner for radians as they do for degrees. So we want to note that coterminal angles can be found by adding or subtracting multiples of 360 or its equivalent of 2 pi, especially when we are talking about radians. So for example, these 3 radians are coterminal with one another. Negative 5 pi over 2, pi over 3, and 7 pi over 3 are coterminal because no matter how we graph those angles, we are going to get a coterminal side. So our coterminal sides are going to align. So now we want to find one positive and one negative coterminal angle with negative 3 pi over 4. First thing that I would highly recommend doing is labeling your main points on your graph so that we can figure out where the original angle is even going to sit. So if we do this, we know we start with 0, and this would also represent 2 pi. Our top is going to represent pi over 2. Our side is going to be pi, and then our bottom is going to be 3 pi over 2. Now, since we're trying to graph negative 3 pi over 4, I recommend going back and converting all of these and rewriting them so that they have a denominator of 4. So we can write 2 pi as 8 pi over 4. We can rewrite pi over 2 as 2 pi over 4. We can rewrite pi as 4 pi over 4. And we can rewrite 3 pi over 2 as 6 pi over 4. All right, now to graph this, we are going to start with our initial side, which is always going to be on the positive x-axis. We're then going to rotate clockwise negative 3 pi over 4, which is going to land us about right here. So this blue graph is going to represent our negative 3 pi over 4. Now, just like in degrees, we are adding and subtracting increments of 360 degrees to this negative 3 pi over 4 to find coterminal angles. Well, we can do the same thing, but by adding or subtracting 2 pi, since 2 pi equals 1 full revolution. So we'll go ahead and find the positive coterminal. We'll start by adding 2 pi to negative 3 pi over 4. However, to add fractions, we need a common denominator. So really what we're doing is we are taking negative 3 pi over 4 and we're adding 8 pi over 4. This will give us 5 pi over 4. Now if we look at our graph, we can start with our initial side and go around 5 pi over 4 counts, and this will be represented by that purple line. All right, now we want to be able to find a negative coterminal. So since it is already negative, if we add 2 pi, we're going to go to positive. So let's go ahead and subtract 2 pi from 3 pi over 4. So really, once again, because we need a common denominator, we are subtracting 8 pi over 4, which will give us negative 11 pi over 4. Now, we know that 8 pi over 4 makes one full rotation. So not only are we going to be doing a full rotation, we will then be going an additional 3 pi over 4. So this negative 11 pi over 4 is now represented by the green line. Okay, so radians are brand new, and we want to be able to convert from degrees to radians and from radians to degrees, just to double check our answers. And dependent on the problem, we're going to be able to need to access different numerical values. So how we do this? We know that 360 degrees is equivalent to 2 pi radians. We know that 180 degrees then would be equivalent to just pi radians. So we have this nice ratio of 180 degrees to pi radians. We can use this ratio to convert degrees into radians and vice versa. So if we know what the degree is, we need to multiply by pi radians over 180 degrees. Similarly, if we want to convert radians into degrees, we are going to multiply by 180 degrees over pi radians. So the nice thing is we are just multiplying by the conversion rate. So if we actually put this into practice, we want to convert 110 degrees to radians. So we're going to start with 110 degrees, and we're going to multiply this by our pi radians divided by 180 degrees. Now something to notice, we can write 110 degrees over 1 just to make it a fraction since we multiply fractions straight across, but our units get canceled. So since we have degrees in the numerator and degrees in the denominator, those units will cancel, and that is why we are dividing by the 180 degrees. So we can multiply this straight across to get 110 pi radians over 180. Now we do not have degrees anymore since they were canceled out. And then all we need to do is just reduce and simplify our fraction as much as possible, which this will give us 11 pi radians divided by 18. So we have 11 pi over 18 radians, and that is equal to 110 degrees. If we want to convert radians to degrees, we are going to start with our radians, so 7 pi over 3 radians, and we are going to multiply this by 180 degrees over pi radians. Now we want the radians in the denominator because once again, our units will now cancel out. Another thing that cancels out in this problem is the pi. So we are now left with 7/3 times 180 degrees. We can multiply this straight across to get 1,260 degrees divided by 3. We can then divide our answer by 3, and we are left with 420 degrees. We can always double check that we did convert correctly by graphing both in radians and degrees and making sure the terminal side is the exact same. Now, on the back side of the second worksheet from the general angles, you are going to complete all of the problems for the radian measures practice. Have a great day.